Angular displacement. Now consider a circle whose path, consider a point whose or an object whose motion is in the path such that it describes a circle. So this is describing a circular motion. Now let the object be at point P. So at any time t, suppose it goes in this anti-clockwise direction. So it has covered this angle theta. So this angle theta is known as the angular displacement of the particle. So if you want to define, so there's an angular displacement, this theta. The angular displacement of an object moving along a circular path is defined as the angle traced out by the radius vector at the axis of circular path at a given time. Now see, OP is what? OP is the radius. So OP is what? This is the radius vector and the particle is going from P to Q. So radius vector has now changed from OP to OQ and the angle that it has covered in going from anti-clockwise direction is theta. So this theta is angular displacement. And also this theta, the angle theta, the value of this theta should be expressed in radians. This should be expressed in radians. So angular displacement theta is to be given in radians. And also by the formula, we know that angle is equals to, this angle is equals to arc by radius. So this theta, so if you consider this as the arc PQ, so PQ is the arc described by this. So angle theta is equals to arc PQ by radius. What is radius? Radius is OP, we can take this as R. So theta is PQ by R. By the formula, angle equals arc by radius. Angular velocity. Now angular velocity of an object in a circular motion is defined as the time rate change of its angular displacement. So this is denoted by the letter omega. So this is known as the angular velocity and as per by the definition. Now if you see this diagram, see, from like the particle is going in the anti-clockwise direction and it has traveled from P to Q making an angle delta theta. So let this angle delta theta that it has described, let it be the time interval delta t. So by the definition, what will be omega? Omega will be delta theta by delta t, and you should remember theta as in radian, or this is equals to, you can by using limit delta t tends to 0, this is delta theta by delta t, which is also d theta by dt. So this is what is the angular velocity. Now see, there are two cases, just two cases right now. This is in what? This is an anti-clockwise motion. Now we know that omega is a vector quantity, so it will have a direction. Now the direction is given by the right hand thumb rule only. So we know that it is going from P to Q. So as you fold your fingers from P to Q, the thumb, which is in the upward direction, means directed upward, perpendicular to the paper, that gives you the direction of the angular velocity. So this will be the angular velocity direction. Now similarly, when it is going down, so it's actually down. So you see your thumb is pointing in the downward direction. So this is what this. So this will be the direction of omega in an anti-clockwise direction. Uniform circular motion. Now see, when a point object is moving in a circular path with a constant speed, that is, it is covering equal distances on the circumference of a circle in an equal interval of time, and the motion of an object is said to be a uniform circular motion. Now in uniform circular motion, the velocity of object is represented by these tangents. As you can see, these tangents, the velocity of object at these points is represented by the tangents to the circular path at a given instant. Now see, the object is moving like this. Now you consider these 4 points. Now though the object, the magnitude, the object speed or the magnitude of the velocity is constant, but still its direction is changing. So though the speed is constant, but still the direction is changing, that means the velocity is changing at each instant. So, this is a case of an uniformly accelerated motion. Now, the time period. Now, the time period is represented by capital T. The time period is what? Is the time period is defined as the time taken by the object to complete one revolution. Now, when it completes this one revolution, this is known as the time period. One revolution on its circular path. It is generally denoted by a T and is expressed in, that's obvious, it is expressed in seconds. Now comes the frequency. Now, frequency is represented as f, or this is nu. This is nu, frequency. The frequency is defined as the motion of revolutions completed by an object on its circular path in a unit time. This is known as per second, this is by per second, or this is represented by hertz also. So, basically frequency is like how many complete circular motion it is doing in 1 second, that is frequency. And you know the relation between frequency and time period, that's frequency is 1 upon time period, or this can be written as 1 upon nu. Nu stands for the frequency. Now let us talk about the angular velocity. Now again, consider a point object describing a uniform motion with a frequency nu and the time period t. Now see, when the object completes one revolution, the angle traced by its axis of circular motion is 2 pi. Now from this point A to, suppose from this point A, now it has covered this motion and it reaches till here. So you know that in complete revolution, it is making an angle theta that is equal to 2 pi radian. This is making an angle theta which is equals to 2 pi radian. And the angular velocity omega, that is equals to theta by t, that is equals to 2 pi by t. So, theta is covered as 2 pi and this is t, this is equals to 2 pi nu, this is the frequency. So, omega is the relation between omega and time period and frequencies. Omega is 2 pi by t and this is 2 pi by nu, because 1 by t is 1 by t, sorry, I am sorry for this, this is actually nu, frequency. So, 1 by t is actually f or nu, hence omega is 2 pi nu. Relation between linear velocity and angular velocity. Now again, consider a point object moving with the uniform angular velocity omega. So, this is the diagram in which it represents the object is moving with an angular velocity omega with a linear speed v on a circular path of radius r with center O. Now, let at any time t the object be at point P, where OP is what? OP is r. Now, at time t plus delta t. Now, at time t plus delta t, because at time t this was at OP. Now, plus delta t means after some time, suppose it has covered a distance POQ, which is delta theta. So, delta theta represents, it has covered, delta theta actually represents the angular displacement. That means the object is at point Q. So, angle POQ is theta, and what is this OQ? This OQ is R plus delta R. Now, it means that, now see, it means that this PQ, you can consider this PQ as an arc. You can consider this PQ as an arc of length delta L in the time interval delta t. Now, we know that according to the formula, V is equals to delta L by delta t, that is just velocity displacement upon time interval, or we can write delta L is equals to V delta t. Delta L equals V delta t, and now we also know that omega, this is equals to delta theta by delta t. This is the angular velocity, angular displacement upon time interval. So, this implies delta theta, that is equals to omega into delta t, omega into delta t. Now, we also know that by the formula angle is equals to arc by radius. Now, the formula angle equals arc by radius. Now what is the angle? Delta theta. And know that this arc is actually delta L. So this is delta L by R. Now substitute the value of delta L and delta theta from here. Now what is delta theta? Is omega delta t, that is equal to, this is V delta t by R. So we cancel. So by the cross multiplication we get V equals R omega, or you can write V equals omega R, that's the same thing. Now in the vector notation is just V, that is equals to omega cross R. So this is the relation between linear velocity and the angular velocity. Angular acceleration. Angular acceleration is represented by letter alpha. So this is how the angular acceleration is represented. Now, angular acceleration of an object in a circular motion is defined as the time rate of change of its angular velocity. So basically, alpha is omega by t, or the way of writing this will be alpha, that is equals to limit delta t tends to 0, which is delta omega by delta t, that is equals to d omega by dt. And the unit of angular acceleration, so unit will be, its unit will be, that is radian per centimeter square. That will be the unit of angular acceleration. So angular acceleration is the rate of change of angular velocity d omega by dt. We know that V equals to omega into r. Now, so this is how this is related, V is equals to omega into r. Now see, if we differentiate with respect to time, so this will give us dV by dt, that is equals to d by dt of omega, and I have taken r as constant. Now why r is constant? Now r is constant because the particle is describing a circular motion. Now for that circular motion, that radius is actually constant. That's why I have taken r constant. Now this is what? D omega by dt. We have discussed what is d omega by dt. D omega by dt is alpha. And we also know that dV by dt is a. So this a, this is equals to alpha r. So this is how the linear acceleration and the angular acceleration are related. In vector form, a vector will be equals to alpha vector cross r vector. Centripetal acceleration. When a point object is moving on a horizontal circular path. Now, we know that this object is moving with a constant speed, but still, you know, its direction is changing. Its direction is changing at every point. So this uniform circular motion is also known as uniformly accelerated motion. Now, this the object who is describing a uniform circular motion is also going under an acceleration that is known as the centripetal acceleration. Now, this centripetal acceleration is always it always acts on an object along the radius towards the circular path. So, if you take this as the line, so centripetal acceleration will be in towards the center along the radius. So, it is always towards the center only. Similarly, from here the centripetal acceleration is directed towards the center from this point, directed towards the center. From this point it is directed towards the center only. So, this is the centripetal acceleration. Now, what is the value of the centripetal acceleration? See, centripetal acceleration is actually given by, I am writing this modulus. So, this is equals to omega square r, which is given as v square by r. So, this is the centripetal acceleration v square by r, which always acts towards the center in a particle performing a circular motion. Now, the illustration. So, our question is, the blades of an aeroplane propeller are rotating at a rate of 600 revolutions per minute. Now, see, this is 600 revolutions per minute. Calculate its angular velocity. You have to calculate this angular velocity. Now 600 revolution per minute is basically the frequency. You can write this as f or nu, whatever you want, which is equals to 600 revolution per minute. Okay, so this you can write 600 by 60 revolution per second, revolution per second. So if you solve this, this will give you 10. So this is 10 revolution per second. Now see, what is omega? We have discussed that omega is 2 pi nu. Now 2 pi, what is nu? Is 10. So this is 20 pi radian per second. That will be the angular velocity omega. So this is the answer, the angular velocity omega. Our next illustration. The radius of Earth's orbit around the Sun is 1.5 into 10 to the power 11 meter. Now calculate the angular velocity and the linear velocity of the Earth. Through how much angle does the Earth revolves in 2 days? So first part is we have to calculate the angular velocity and the linear velocity of the Earth. Now for this, see, they are saying that velocity of the Earth. First of all, we know that Earth takes a complete round in 1 year. We know that the radius of Earth which is given to us is 1.5 into 10 to the power 11 meter. And also we know that the time period of revolution of Earth around the Sun is 1 year, which is capital T. So it's better to convert this 1 year to seconds. Actually 1 year is how much? This is equals to 365 days. So which is equals to 365 into 24 into 60 into 60 seconds. This will be the time in seconds. Now first of all, we have to find the angular velocity. Now what is the angular velocity? Angular velocity omega is 2 pi by t. Now substituting all the values, this is 2 into pi is 22 by 7 upon the value of this is 365 into 24 into 60 into 60. Okay, so now on solving this, if you solve this, you will get this as 1.99. You can write 2 also, rounding it off, into 10 to the power minus 7 radian per second. That is radian per second. So this will be the angular velocity. Now we have to find the linear velocity. We know that the linear velocity, the relation between linear velocity and angular velocity, V, that is equals to r omega, or omega into r. So radius is 1.5 into 10 to the power 11 into what is omega? Omega we have calculated 1.99 into 10 to the power minus 7. So this is equals to 2.99 into 10 to the power 4 meter per second. This will be the linear velocity. Now the last part is how much angles does the Earth revolve in 2 days. Now you have to find the angles that Earth is revolving in 2 days. So basically, see, in 365 days the Earth completes 1 revolution. Therefore in 365 days the Earth revolves. So in 365 days, 1 revolution means Earth revolves to an angle of 2 pi radian. Okay, so in 2 days, say, applying the unitary method, see 2 pi in 365 days. Okay, so this 2 pi by 365 will give you in 1 day. For 2 days, you multiply this with 2, which is equals to, if you solve this, this will be 0.034 radian. A motor car traveling at 30 meter per second on a circular road of radius 500 meter. It is increasing its speed. Now this is also what it's doing, increasing its speed at rate of 2 meter per second square. What is the acceleration? Now see, first of all, this object is undergoing 2 acceleration because this is circular motion, so there will be an centripetal acceleration which is directed towards center, and also it is increasing the speed. Now this is not a constant speed, this is increasing the speed at a rate of 2 meter per second. So therefore there is also which is known as the tangential acceleration. We know that these two are at 90 degree to each other. So the resultant acceleration will be along this direction. This is the acceleration and we have to find its value. Now see, here the speed is what? Speed is 30 meter per second. So this is 30 meter per second is the speed, and radius that is given is 500 meter. Okay. We know that AT is given, which is 2 meter per second square. This AT is 2 meter per second square. This is the acceleration. Now what is the centripetal acceleration? Centripetal acceleration AC, we have discussed, this is given by V square by R. So substituting the value, V square is 30 into 30, R is upon 500. Now you can solve this, which will give you this as 1.8 meter per second square. Okay. Here AT is acting tangential to the circular path, AC is acting along the radius towards the center of the path. So effective acceleration will be this. Now we know that these two are at 90 degree to each other. So A means the resultant acceleration will be given as under root of AC square plus of AT square. That is under root of 1.8 square plus 2 square, that is given to you. So net acceleration is actually 2.7 meter per second square. Sorry, 1.8 square plus 2 square, the net acceleration is 2.7 meter per second square, and this is the net acceleration.